4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. All right, parent function, parent quadratic function is graphed. Now, I want you to see something here, because I want to look at f of x equals negative x squared. F of x equals negative x squared. All right, so all I'm going to do is, instead of x squared, I'm writing negative x squared. Does everybody see that? So 9 goes to negative 9. 4 goes to negative 4. 1 goes to negative 1. 0 goes to negative, that's still 0. Negative 1, negative 4, and negative 9. Is everybody good there? So if I plot the same x versus this new y, let's do that. Let's do that. Negative 3, now it's negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, negative 4, 2, 3, 4. Negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. Now I'm going to draw that. Any questions there? You see what's happening there? All right. Now, f of x equals x squared. We know the domain is negative infinity to infinity, and the range is what? Oops. Quick. Caitlin? Okay. I'm going to do this. You're doing the transformed one, aren't you? Yeah. Okay, so I'm going to do what you just said. Well done, because that throws people off to start with negative infinity. She's talking about the pink one here. The low doesn't have a low. It starts at negative infinity and 0, and we'll put a square bracket on 0. Okay, for the parent function, it's 0 to infinity. Does everybody understand this range? It's always low to high. Okay? Good job. Now, it says describe the transformation of f of x equals x squared from g of x equals ax squared when a is less than 0. I put a negative here, so I put like a is negative 1. Describe the transformation. What happened? What happened here? Okay, so it flipped over the x-axis. All right, that is well said. Now, the more technical term is it reflected over the x-axis. All right, so when you have a negative, with positive, this thing's opening up. If you have a negative coefficient there, a is less than 0, that's a negative number, right? It's going to open down. All right? Okay, that's the one thing, that's a reflection that we're talking about. And, oh, there we go. Okay, now we're going to talk about dilations a little bit. When's the bell ring? 46. All right. So we're going to graph f of x equals the absolute value of x. I'm going to graph a few of them here, okay? Now we know how this one goes. If I go -3, -2, -1, 0, 1, 2, and 3, this is 3, 2, 1, 0, 1, 2, and 3. And we go like this. And we go like this. Right now, we're just trying to figure things out a little bit. And let's try f of x equals 2 times the absolute value of x. All right? Well, I have the absolute value of x here. I need to take 2 times that. Right? So 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. All right, so I multiplied each one of the absolute value by 2. All right. I'm going to do this in pink. This is still my x-coordinate. These are my new y. You with me here? Okay. So I'm going to plot -3, 1, 2, 3, 4, 5, 6. -2, 1, 2, 3, 4. -1, 2, 0, 0, 1, 2, 2, 4, 3, 4, 5, 6 is here. Looks like we're going up 1 over 2 here. If I put a couple more points on so I can make a nice straight line on both sides of the V. Okay. Now, I just multiplied it by, it says, okay. Let's change this. I didn't edit this. Let's change this to absolute value of x. And change this to a times the absolute value of x. All right? We'll do the same here. Absolute value of x. A times the absolute value of x. All right? Let's describe. So, what has happened to the parent function when we multiplied it by 2? It did get narrower. Okay, what's actually happening, this point and this point correspond, this one and this one. Do you see how it's stretching? When we're stretching it, it makes it narrower. Okay. So it got narrower, and we're going to say it gets narrower. And literally what is happening is it is, and that makes it stretch. So it is stretched by a factor of A. That A is that number in front of the absolute value. So it's getting stretched. All right? Now, let's make one more column. This is probably all we're going to get done today. F of x equals 1/2 times the absolute value of x. Okay? Now, guys, this time I am... right here. This time I am still working with this. Half of 3, would you guys, if I use decimal, you all right? 1.5? Half of 2 is 1. Half of 1 is 0.5. Half of 0 is 0. Half of 1 is 0.5. Half of 2 is 1. And half of 3 is 1.5. Okay, so I'm going to use this color here. And this is still, these are still my x-coordinates. I'm being lazy. I'm not writing x-coordinate new table for x every time. So -3, 1.5 is right here. -2, 1. -1.5, still 0, 0. 1.5 is the y-coordinate. 2, 1. 3, 1.5. I'm going to just try to keep that going. Now look at that. So what happens here? Describe the transformation of f of x equals absolute value of x from g of x equals a times absolute value of x when the absolute value of a is somewhere between 0 and 1. Like 1/2 is between 0 and 1, right? What happened to our graph?
It
Got wider. It gets wider. And we say here, we're actually, it's like you're pressing down on it. All right? And we will deal with that visual. Write this down. It is compressed. I'm going to write by a factor of a. Bring the packet tomorrow, okay, guys? We will get into this a little more.